even though it's like identical to a problem code.
Okay, any questions? I apologize for the late start here.
So our test is
It's-
on the 5th.
A week from tomorrow.
Okay.
Oh, I see.
Do we, this is not because I'm wanting us to add it in, I'm gonna preface it with that, it's just a question. Did we not have homework quizzes as like review just because of like the time crunch?
I feel like, yeah,
It would have been.
just the timing didn't quite work out nicely. So the homework quiz for chapter 21 basically is
Master set.
well, no, the homework quiz, it's a problem like this.
Okay.
And so that'll give you one more chance to practice it before the test. And I've done in the past where whichever one you do, if you nail it on the quiz, then I'll count that one for the question on the test. Or if you get the one on the test, I'll count that one for the quiz. Whichever one you do better on, I will count for, in both slots, for the one question on the test or and the quiz. So if we did that, that means that that quiz would have to be on the 27th or the 4th, if you were interested.
In what?
From grade wise. All right, the question that's gonna look like that, like was on Master Set 21, except it was
Right.
drawn funnily. Yeah.
Right.
The last question on test 1B will be something like this.
Okay.
Basically the same orientation, except the batteries might be flipped upside down.
Right.
All right, so the quiz, the homework quiz for chapter 21, it's basically that problem. So what I've done in the past is whichever one you do better on, if you do better on the homework quiz than you do on the last problem on the test, then I will take that homework quiz score and give that to you on the test.
Mm-hmm.
If you do better on the test, then the last question on the test, then on that, then I'll take the last question on the test answer or score, and I'll give you that for the homework quiz. So, we currently don't have homework quiz 21 up there. We could, and I can run the same deal, or we don't, in which case, you don't have that 2 chances to get it right.
2 chances.
I'd appreciate it. I'd appreciate 2 chances.
Yeah.
Plus it'd be good to like practice it.
All right, so the question is, do we do it on the 27th or on the 4th?
The quiz, the test would be
The test is a week from tomorrow, Wednesday,
tomorrow.
next week.
Before or after the weekend is really the question. Before.
I think so it's fresh.
So, I'm feeling there's almost a
I guess
groundswell
we're in
there.
agreement?
What do you think?
What do you think?
All right, so March 4th.
Yeah.
Is there second thoughts about that?
It's good.
Okay,
Good.
tell us how you feel.
That's good.
Okay.
Yeah.
Yeah. Yeah.
That way we have 2 chances to get it right.
Well, you had 2 chances even if you did it on Thursday.
Yeah.
It'll be
But then we
fresh.
also have the weekend and it'll be fresh.
Okay.
Mm-hmm. 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 Plus we love physics. We love doing these equations.
Yeah.
So much.
We all
Don't
know
take
that
this
physics
joy
brings
from
out the
us.
love.
Am I allowed to ask a question about something on the master set?
Yep.
Okay.
the thing that you handed in?
Yeah, I just was curious if you could. Nope, that's actually
The other
the,
one?
yeah, no, yeah, the.
Chapter 20?
That's the one I have a question about.
Conveniently, it was the next one.
This,
Yes.
you said that you had a 1 point
Yep.
however million R squared value.
Yeah, that makes it suspect, but sure.
So no matter how many, I found the error that I made on my math, but no matter how many times I ran through each of the equations, they all were like, some of them were still too high, some of them were still too low. Granted, the average of all of those numbers was pretty close, but I was just curious if you could run through a problem like this.
All right, so
Cause that one was kind of confusing.
Yeah, I wasn't sure about that one either, I ended up just doing the total average and I thought.
Yeah.
I know that resistance is equal to rho L over A, whichever L you're using.
Yeah.
Rho L over A. And I was about to say the lab that you did, this would be the video lab, right?
Wait.
What was the lab that I gave? It's the resistivity lab.
Resistors in series and in parallel, yeah,
Oh, so, okay,
that's the video lab.
so this is the resistivity lab, which you actually physically did 2 weeks ago.
Oh,
No,
yeah.
3 weeks ago. Because this was snow.
Yeah,
Quotation
it's
marks.
up there also, probably. In the pile things I turned in.
So that would be the 5th.
Yeah,
You did the resistivity lab.
I know,
All right,
disappointing.
so you were measuring resistance, you were varying L. So that would be your dependent variable. And L is your independent variable. Putting it into y equals slope x plus b form, we have r is equal to rho over a L plus 0. So this equation and this equation are the same thing. I would expect the intercept to be 0, and I expect it to be linear. So I gave you AWG 39 wire. So you can look up what that, oh, I gave you the diameter. So you know the diameter, so you know A. So the slope should be rho over A, or the resistivity is equal to the slope times the area. Area you can figure out because I gave you the diameter. The tricky part here if you're measuring this, I got a wire and I'm measuring the resistance of different lengths. So I've got my probe here, I got a connection, and then I got my piece of wire. This has some resistance, not just the wire itself, but the stuff I'm connecting to the wire has its own resistance. So what I'm actually measuring here is the resistance of my wire plus the resistance of everything else. So resistance of, I'll just write E for everything else, plus the resistance of the actual wire itself. So really, we have, since I'm measuring the resistance of, well, actually, I'm measuring the whole thing. That's going to be equal to RW plus RE. I feel like I got a minus sign off somewhere, but it's not going to change what I'm shooting for here. In other words, I would expect there to be, something's off in my explanation, but I would expect the resistance that we're actually measuring would be resistance there's some base resistance of all of this, plus the wire. So I would expect the points actually to hit like that in reality. If you just do, oh, I know that rho, so here's the common mistake. Rho is equal to RA over L. So you take the resistance, you take the length, you take the area, you just plug it in there, get a resistivity. What you've actually done is, if those are my data points like that, what you've done is you've taken that slope, and that, and that, and that. You haven't done the slope of that.
Yeah.
So if you did, because the results are so perfect there, because, you know, it's a physicist's fantasy. If you had just done not R over L, but change of R over change of L, you would have gotten the right answer. But I think I have it set up so that if you're just doing R over L, you, for the data points, you get actually a different material every time.
Yeah, so I took the average of all of them, and it gave me one number, and I just went with that.
Yeah.
Should I take it back? No, it's okay.
It's a common mistake,
Okay.
and deliberately set up so that this even falls into it. And I know I've mixed metaphors there.
Trap
The first version of this master set, I had it so that it actually went through the origin and you could get away with that. And I thought, no, that's just, it's not realistic.
Yeah.
Not that R squared of 1.000000 is realistic.
If I were to redo just the scroll at home, would you be opposed to checking to see if I did it correctly?
I would not be opposed.
Okay. Not necessarily, not for credit or anything, just I want to know if I did it right the next time. Well, you're sneaky, Dr. Bob.
That one I was, yes. Other questions? Let's talk about magnets. When I say words and I sort of drop consonants, I think, am I becoming my dad? I just inevitably, in some form or another, cannot escape traces of our parents. All right, so we got a long wire here. We'll just say infinite wire. And we'll have the current going to the right. Which direction will the magnetic field be running? All right, see, one person got out, that right hand. That is correct. Okay. They got two people with their right hands out.
Yeah.
Now, the three of you don't. And it looked like you were just hitchhiking. And popping your joint there. All right, so the current's going in that direction. The magnetic field is running out on top and in on the bottom. So to represent out with the dots. And then in crosses. And I was trying to also give some sort of feel for, I have fewer dots the farther out you go, or fewer X's the farther out you go, because the magnetic field weakens. And I know that the magnetic field is going to be U naught I over 2 pi r. That's magnetic field strength. The direction is, it depends on where you are. Speaking of which, let's see how much you remember. If I have a loop of wire with a current running counterclockwise, what is the magnetic field in the middle? Magnetic field strength in the middle. Okay, first, either direction or formula, without looking. All right, so we have one person indicating a direction. Does anyone else agree with you? So, oh, I'm not seeing Ryan making any hand gestures, so I'm not quite sure if you're trying to go for it or not. Anyway, yes and yes. Jackie, did you have an opinion? That way. And Erica?
I don't know.
Okay. And Ryan, did you figure it out?
I don't remember.
Okay. So if you wanted to do it by the same rule we did over there, well, at this point right here, the magnetic field is going in on the outside and out on the inside. And matter of fact, no matter where I am, in the middle of it, the magnetic field's coming this way. Outside of it, it's going that way. So the magnetic field in the center would indeed be out at you, which we'll say the majority of people said. What is the magnitude? Oh, backing up. Also for this case, if I've got a loop of wire, I can also do the right-hand rule of my current's flowing around like that, my thumb points in the direction. All right, so the formula, it looks similar to, but it's not the same as the one we have over there. Yes?
Did you just get rid of the pi?
Yes. So it's mu naught I over 2r. And again, emphasizing that the straight wire creates a circular magnetic field. Thus, that's where the 2 pi comes in, or 2 pi r comes in, that's the circumference of a circle. And over here, it requires calculus and application of B of r to derive that, which we will not do. But I might have mentioned it before, but if you are interested, send me an email, I'll send you a link to a video where I go through that. So, actually, looking back at this formula here, so mu naught I is equal to 2 pi r times the magnetic field. Playing a little fast and loose with some of the notation, but the essence is there. This 2 pi r is just the circumference of a circle. So I'm just going to write that as b times, we'll just go c for circumference, not capacitance or coulombs. So in general, we have this magnetic field. If I'm a certain distance away from the wire, I would expect the magnetic field strength to be the same. Anywhere the same distance. And that's right, we can't find the hula loop anymore. This was very convenient. So if this is a wire and current's running through it, or model that, running through it that way, and I'm this, and assume it's thin, and I'm at the same distance from the wire, everywhere at that same distance, the magnetic field strength should be the same. So, if I take the magnetic field and I sort of add all the magnetic fields along that line there, I basically have B times how far the path is, the length of the path. Well, since the magnetic field travels in different directions, I mean, really, that's a vector there. I need to somehow come up with a math way of expressing that. So what I'm gonna do is I'm just gonna write, I'm doing the sum of the magnetic field and a dot product with, we'll write delta L. And I'm doing it around a full loop, not just going half measures. So I'm taking some path and I'm going all the way around back to where I started. So I add up the magnetic field times that length, I'm gonna end up with mu psi U naught I. Not a full derivation, but it hopefully gives some indication that if I write this, there's some credibility to it. Which I guess the credibility is based on the fact that you're trusting me that that's true. This, Ampere's law. It is the third of Maxwell's equations. Ish. And the reason why I threw the word ish in there is that there turns out there is a piece missing that Ampere did not realize. It's this piece right here, the Maxwell correction, that basically is used to derive the speed of an electromagnetic wave, which is next chapter. All right, questions to here? How many people in here have had Calc 1?
I'm in it now.
Yeah, okay. 8-week course? So you're almost done, or you just started?
Almost.
Almost done, okay. You got the antiderivatives?